Hi, my name is Aizam Shari. Today I will tell you all about what is Oedometer Test and when we do this Oedometer Test. Oedometer Test is the consolidation test that used to evaluate the rate and magnitude of soil settlement. The settlement benefit achieved from this examination is only attributed to primary consolidation, which is 90% of the overall consolidation. And now, where we usually do this oedometer test. For samples that are saturated with water, porous stones are placed on the top and bottom of the sample to allow drainage in the vertical direction. And the entire sample is submerged in water to prevent drying. Saturated soil sample exhibit the phenomenon of consolidation, whereby the soil's volume changes gradually to give a delayed response to the change in applied confining stresses. That's all from me. Thank you.
Next is why oedometer test is conducted. Because it is very helpful in design of foundation and determine the stability of structure. Oedometer test is occur when a load is applied in a low permeability soil. It is carried by the water that exists in the pores of the saturated soil, resulting in a rapid increase of pore water pressure.
Before we proceed to the procedure, let me list down the equipment or material that we use during the test. Firstly, consolidation apparatus, which is consolidation ring, corrosion-resistant porous plate or porous stone, consolidation cell, dial gauge and loading device. And then continue with balance readable to 0.1 gram, vernier caliper, stop clock readable to 1 second, and lastly is moisture can.
The testing process starting with first using internal vernier calipers, calculate the internal diameters and thickness of the ring as shown in the figure. Next, the mass of the ring to the nearest 0.01 gram is determined. Third step for the test, prepare a soil specimen. Place the specimen of the soil in the ring and trim the bottom and top of the loop. The fourth step, determine the initial moisture content from the trimming soil. After that, determine the mass of the ring with specimen as in the figure shown. Next, saturated the lower porous stone on the base of the consolidometer as shown in the figure. After that, set the specimen centrally on the porous stone in the ring. Fit the retainer and side body of the ring and then centrally position the upper porous disc on the top of the specimen as shown in the figure. Next, place the consolidation cell on the system base platform centrally in place.
Next, lift the end of the pin to allow the loading yoke to be raised to the vertical position and adjust the loading stem by screwing it downwards until the end engage closely in the races on the top of the loading cap as the picture shows. Number 11. Attach the compression dial gauge to the arm of the support post. Number 12. Add water at room temperature to the cell to submerge the soil and keep it saturated as the picture shows. Number 13. Apply load carefully to the load hanger as the picture shows. Number 14. Wind down the beam support and at the same time start the clock. In addition, observe the compression dial gauge readings and the clock and record the readings on the consolidation test form at the selected time intervals like the picture on the side. The next day, add more load to the specimen. Take the compression dial gauge readings at similar time intervals as the picture shows. Number 17. At the end of the test, remove the soil specimen and determine its moisture content like the picture on the side. Last but not least, plot the readings of the compressions against time to a logarithmic scale and against square root time. That's all from us. Thank you.